My name is Nicola, aka Socrates, and you're watching Singularity One-on-One. Singularity One-on-One is a regular feature of Singularity Weblog where you can go and download it or listen to it for free. If you guys enjoyed this show, you can help me make it better by writing a brief review on iTunes or by simply making a donation. As always, I will be the man with the questions, and today, my guest with the answers will be Louis Rosenberg. Louis has a PhD in robotics and virtual reality, and he's also an entrepreneur, inventor, engineer, scientist, and an AI researcher. He's the founder of Immersion Corp, which went public in 1999 on the NASDAQ, and most recently, the founder of Unanimous AI, a company that aims to harness collective intelligence. So welcome to Singularity One-on-One, Louis. I'm so happy to have you on my show.
Yeah, thanks for having me. I'm excited.
Fantastic. So let's jump right in and let me ask you, what's the best way to introduce yourself in your own words to our audience, which may not be familiar with you and your work before?
Right. So, like you said, I'm Louis Rosenberg, and the company that I recently founded is Unanimous AI, and our interest and my interest is in what we call artificial swarm intelligence, which is a use of collective intelligence to form an artificial intelligence. And our primary interest is creating an artificial intelligence that keeps people in the loop, that keeps humans as part of the process, as opposed to being entirely software, entirely machine-based.
That's totally fascinating, and we will definitely go into depth into this. But before that, let me ask you this. How and why did you get interested in technology in general and artificial intelligence in particular, perhaps?
Yeah, my interest in technology goes really starts at people. And so when I was in college and in graduate school, I was really interested in human perception, which is what got me interested in virtual reality and augmented reality, but also artificial intelligence. And all of those technologies have that one thing in common, which they're really about biological aspects of the human experience, whether you're trying to enable them or simulate them or replicate them. And so I've always been interested in those boundaries between humans and machines, how people interact with machines and how people interact with software, and how we can use technology to improve how people experience the world.
So what then is your motivation and what is your main goal?
So my real interest and motivation for what we're doing at Unanimous AI is to use technology to amplify human intelligence and to harness the fact that people are smart, but groups of people are even smarter. And there's 100 years of research that goes back to the very first experiments in 1906 by Francis Galton, where he looked at the wisdom of crowds. And so you hear this idea of wisdom of crowds, and all the way back in 1906, he did this kind of interesting experiment where he said he was at a county fair in London, and he asked 700 farmers to estimate the weight of an ox, and as individuals they were wildly all over the place, but when he took the mean of all those estimates, they were astonishingly accurate. And over the last 100 years, lots of research has shown that people, when you harness their intelligence in groups, when you combine their knowledge and wisdom and intuition, people get really smart. Groups are smart, and yet the technology for harnessing groups hadn't really changed since 1906, which was just taking the average. And so we started looking at technology. How can we use far more interesting, sophisticated technology? How can we leverage the fact that the world is now a networked place where people are connected, and really create a collective intelligence that's more powerful than just taking a simple average of numbers?
That is absolutely fascinating. But let me stay a little bit still at the kind of zoomed out level, at the macro level for the next couple of questions before we zoom in and dive all the way into the nitty gritty of the things. So, what is your biggest dream? What is that kind of vision that drives you? What is like the final best case scenario for you that keeps you going through the difficulties, that makes you want to overcome anything that's on your way?
Right. So for the technology that the technology development efforts that we're doing, my real interest is to amplify intelligence, to see if we can create a an intelligence that exceeds human abilities and do it in a way that keeps human morals, human intuition, human ethics, human values in the loop as part of the process, as opposed to this the path that most AI research is going down, which is create, which could lead to a super intelligence that does not have human values, human intuition, human morals in the loop, and might not even have interests that are aligned with our own. And so for me, the thing that really pushes me towards this direction of artificial swarm intelligence and collective intelligence is to say, there is an alternative for creating enhanced intelligence that doesn't have to replace people. It can actually incorporate people, and for me, that's a safer path. I see the path of pure artificial intelligence research as kind of dangerous. It's dangerous because if it really achieves its goal, which is to enable an intelligence that doesn't just match human intelligence but exceeds human intelligence, we have no reason to believe that purely artificial intelligence will have any interests that are aligned with ours, that will behave in ways that we even understand. Uh, and so for me, can we keep humans competitive in in the intelligence landscape? And uh, the one thing that we have are billions of us, and we're very smart as individuals, but we're even smarter in groups, and we can create technologies that allow us to to be very smart if we can think together, make decisions together, be creative together, and and the technology that we're pursuing is really aimed at unlocking that.
That is a very beautiful and a unique vision, but the flip side of that coin of the dream is the fear. So I think you kind of touched a little bit on it, but tell us a little bit more about what is it that's your biggest fear? Is it like artificial intelligence surpassing human intelligence and being totally disconnected by it? Because that's kind of like what I found implied in your previous answer.
Yes. So, I mean, to me, it's a matter of time before artificial intelligence can match human intelligence and ultimately exceed human intelligence. I don't necessarily think it's going to happen as quickly as some others think. I mean, there's some who think that that's going to happen within the next couple decades. I think it's further out, but I do believe that the path of artificial intelligence research will ultimately get us to the point where we can create completely artificial machines that are smarter than us.
Hmm.
And once they're smarter than us, then they don't even need us to create them. They can create themselves. They can improve themselves, and they will leave us far behind. And 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 again, that's interesting and that's exciting. The problem is we have no reason to believe that an artificial intelligence, although being powerful, will have sensibilities that we can even relate to, or would even find us to be useful in this world. An artificial intelligence will have its own interests, will have its own goals, will have its own aspirations, and to think that we can control it, to think that we can design into it a desire to be benevolent to people is maybe a little bit optimistic. I mean, we have technologies have a way of always getting out of our control. Technologies have a way of having unforeseen consequences, and I see artificial intelligence as a technology that could have very profound unforeseen consequences, especially when it becomes smarter than us.
Hmm.
uh, and so that fear is part of my interest in my desire to say, well, how can we humans get smarter ourselves? How can we pool our knowledge and our uh, our creativity to be smarter together and stay competitive, or even always stay one step ahead of the pure software intelligences.
So, in a way, your work is aimed at mitigating and perhaps diminishing the risk of AI surpassing human intelligence by kind of aggregating and creating collective human intelligence to equal or compete or maybe even outmatch AI. Is that the idea?
That's absolutely the case. So the case, it's can we use a combination of AI technologies and human input to create intelligent systems that are smarter than ourselves, and thus basically pushing the bar further and further out for a machine to exceed us. If we can be smarter together, if we can create a collective intelligence together that makes very smart decisions or solves really hard problems, but does that with people in the loop, does that in a way where when we solve hard problems, our human interests are integral to the way we solve it. When we solve hard problems, human emotions and human morality and human values are part of the solution because we're part of the system. If we can create that enhanced level of intelligence together, then the bar for a purely artificial intelligence to exceed us has been raised. And we push out further in the future the place where we would potentially be uh, surpassed by completely software driven intelligence.
Yeah, I was going to say precisely that because what it seems to me, what you're doing is pushing the goalpost forward. That would eventually give us more time, but in the end of the day, the result may not be actually that different because let's say even if you aggregate the collective intelligence of 8 or 9 billion people, that's still a finite number that's underpinned by biology in some way or another. Whereas the alternative software AI, hardware AI is underpinned by Moore's law and exponential growth. And therefore, while that may give us some breathing room and more time to kind of figure things out, in the end of the day, Moore's law would beat biological uh, aggregated intelligence, it seems to me. Isn't that the case?
It is. I mean, if in that level of abstraction, it's absolutely true that we can think of human collective intelligence as pushing the goalpost out, but will that will we ultimately always be overrun by a purely software intelligence? My hope, and the thing that I that gives me hope that that could potentially not happen, is that as a collective intelligence, we potentially could make better decisions. We could potentially make more unified decisions that are in our best interest because we're actually thinking together. And if we do that, we might do a better job at controlling the purely software intelligence.
Hmm.
And I say that in that humans have a hard time at making decisions that are in our best interest. We create problems uh, like global warming, for example, which uh, doesn't make sense from a collective perspective. It's because we have a hard time making decisions that really incorporate all of our knowledge and all of our intuition and all of our interests in a way that's the best for humanity itself. And we keep getting better and better at at doing that, but it's a challenge for us that leads to bad decisions and leads to technologies getting out of control. And so my hope is that if we were able to create a collective intelligence that is smarter than us, we might be able to make decisions that are better than the decisions we're making now, and be able to better control the technologies we create so that they don't become dangerous to us.
Hmm.
Uh, there's obviously, we can't eliminate the risk. There's always risk, but giving us more time and allowing us to make better decisions at least puts us in a a better chance at,
Yes.
at not having technology overrun us, whether it's intelligent technology or other technologies that have unforeseen consequences.
Louis, one thing that I'm always kind of interested is not only the work of my interviewees, but also sort of their personal characters and sort of uh, traits, if you will, because I find them to be kind of illuminating, at least to some degree, and relevant to our discussion of revealing sort of the person behind the work. So let me ask you this kind of perhaps unrelated question. You're a vegan, are you?
I
Aren't
am.
you? Yes. So why are you a vegan? Is that for ethical reasons or for health reasons or both?
It's for ethical reasons, although the health benefits are. I believe the health benefits are real, but for me, it's ethical in terms of as somebody who spent a long time thinking and looking at intelligence. It's very clear to me that the animal kingdom is full of intelligent creatures that have uh, their own emotions and their own lives that are just as rich as ours. And in fact, if you if you're an artificial intelligence researcher, you should be actually amazed and impressed with the intelligence levels of almost all animals that you interact with. And so, if you respect intelligence and you're trying to emulate intelligence, uh, it seems wrong to eat intelligences when there are alternatives, and you can very easily be even healthier if you're eating a plant-based diet.
Hmm. Fascinating. And I have to admit that it's one of my own personal character weaknesses in the sense that I absolutely agree with you that from ethical point of view, being a vegan or at least vegetarian is the right thing to do. From health point of view, however, I am quite not convinced that may be the case yet. And and so this is one of those very few rare things that I admit total character failure on my behind, where usually I try to follow the ethical choice, no matter the cost. And this is probably the only exception I can think of where I'm failing miserably to live to my own ethics. And that doesn't probably say many very good things about me. But hopefully, those artificial super intelligences would have the same level of ethics that you are exhibiting, and they would kind of have the same empathy for us that you're showing for lesser intelligences.
All right, that's a great point. Which is, uh, we would hope that if an intelligence does exceed us, they don't consume us for resources the way we
Exactly.
consume other intelligences as a resource.
Right, right, absolutely. That's my hope. But let me move on to your company. So tell us a little bit about Unanimous AI. When did you start it? Uh, what's the team like? What's the sort of the work you do? The major products, perhaps.
Right. So we've been working on this for almost 2 years. Um, our our technology that we're developing, uh, we call artificial swarm intelligence, but we're building it as a consumer-based platform that we call UNU. And um, and the idea of UNU is to allow people to anybody to log into an environment that looks very much like you would log into a gaming server or a chat room, but instead of just chatting with other people, you can actually form a collective intelligence with them. You can form a swarm, and you can ask and answer questions about anything. And
Hmm.
so we've been in beta testing with lots and lots of users, and they'll come in and they'll ask questions and answer them collectively about sports or about politics or about just big issues. We have futurology people coming in and talking about making predictions as a group about the future. There's lots of really interesting things that people can do by tapping into their combined knowledge and intuition and emotion. Our team is based mostly in the Silicon Valley area, but we're distributed in various locations. We have some folks on the East Coast, um, and really are all of us on the team are really interested in creating an environment that will allow people to tap into the collective intelligence of groups, but make it available to everybody. and also make it fun. And one of the things that we found is that people find swarming, answering questions as a swarm to be fun and to be interesting and to be fascinating. We've also found that it has to be fun, or we won't get people to do it. If our goal is to get hundreds or thousands or tens of thousands of people to answer a question together in a swarm, if it's not fun, they won't do it. If it is fun, then they're happy to jump in and participate in these collective experiences.
Mm-hmm, mm-hmm. Okay, so let's try and start actually addressing and perhaps defining the main terms that pertain to sort of your work. So first of all, what is a swarm and how is it different from from a crowd?
Right. So a swarm is basically a group of people, or it could be. I mean, swarm comes from nature, so it could be a group of any type of independent agent. Is what we would call them in the AI world. But it's a group that will form a system that is actually a closed loop system, meaning they are reacting to each other in real time. So they're reacting to each other in real time. They're able to negotiate and reach decisions in parallel. And so a decision will emerge from a swarm. Typically, when people talk about a crowd, especially in the context of like the wisdom of crowds, they're usually taking a poll or taking a vote. And those are usually done what we would call asynchronously, meaning I can poll 1,000 people and do that independently to each of them. They have no interaction among themselves. They're not pushing and pulling off each other. I'm going to get their discrete input from 1,000 people, not even at the same time. And I'm going to find the average, and I'm going to get what basically is a snapshot of what that group thinks. And so a crowd is really analogous to a poll, and a swarm is really analogous to a system. And what's interesting is that a poll is very often polarizing, meaning I can take a poll of a population and it will tell me the difference. It will tell me exactly the differences among that population. It will tell me this percent of the population thinks this and this percent thinks that. And in fact, if I publish that poll, all I will do is get that group to be more entrenched. And so the polls actually drive further polarization. And so it's actually a really bad way to tap the wisdom of crowds, because what you're really doing is you're exposing the extreme views and even driving the extreme views. Mm-hmm. A swarm does the opposite. A swarm, as opposed to being polarizing, is actually unifying. It's actually asking a group to consider an issue together and actually negotiate in real time. They're pushing and pulling, and they're finding the solution that that the whole group can best agree upon. And so with a swarm, you might not reach the decision that is the most popular, but you will reach the decision that the group can best agree upon, that the group can best accept, that actually maximizes the satisfaction of the group, as opposed to just taking the most popular answer. Mm-hmm. And so swarms and crowds are actually pretty different. And from our perspective, swarms have the potential to actually allow groups to find common ground, whereas crowds tend to shift towards the extreme and have just one voice that drowns out everybody else.
Mm-hmm. That's fascinating. So your platform, as you said, it's called UNU, and that's a swarming platform. So tell us perhaps a little bit more about your platform.
Right. So
how does it work and so on?
Exactly. So anyone can log into UNU, and they would be like logged into a chat room or a gaming server, and they get a username, and then they jump in, and they can chat with everyone else who's in a particular swarm. And so just like a chat room, which would have maybe 100 different topics that people are chatting about, inside of UNU, there could be 100 different topics that people are swarming about. And they can go in and they can swarm, and then they can go in and they can chat, and then they can also ask questions and answer questions to the whole group. And so I might ask a question, who's going to be the next president of the United States? And now the group can propose suggestions, and then we might have we might have 6 suggestions that we're going to then decide upon as a swarm. And the way we would decide upon it is we collectively control a pointer on the screen, essentially, and we can all pull on it together to have it reach an answer. But we're doing it in real time as a closed loop system. So we're pushing and pulling on each other. We might all be reaching a stalemate where if everyone's pulling in a different direction, we're going nowhere. And so what happens is people will switch their views in real time. And so if somebody switches their view and somebody else switches their view, and it's all happening in real time, you'll find that solution very quickly that we can all agree upon, and we will experience it together. And a good way to understand it, because it's abstract, is just actually see what it looks like. And so I can show you, if I can get this screen share to work, I can show you what.
Sure.
Let's see, desktop.
It's one of those things that you actually have to see for yourself to kind of get the idea. So let's see if we can make the share screen work here for a second.
There
you go.
Okay, so can you see this? This is a swarm. It says which candidate appears to be the most presidential. And this was This was a swarm of about 100 people, I think, who are answering this question together. As you can see, they're controlling that glass puck, and every one of those magnets is a person working together, and they're pulling that puck together, and they get Hillary Clinton.
I see.
And I can ask, here's a different example. And so here's an example where we actually asked a group of people with very mixed politics, what should be the priority for Congress, which is a very tough question, and yet they quickly converge decision jobs. And what happens is we see these decisions emerge very, very quickly. But if we look at the data over time, even if it's all happening over 10 seconds or 20 seconds, very sophisticated negotiation is happening, where people are pulling towards one choice, realizing that their choice maybe is not going to be supported. They see the puck moving towards a choice that they really dislike, and so they go from pulling towards their first choice to defending against a choice that they dislike. But everybody's doing that together. So people are pulling towards choices that they want, defending against choices they don't want, and quickly an answer emerges that maximizes the sentiment and the satisfaction of the group. And so here's another example we can look at. So we asked a group to predict. This was a couple months ago. The movies that were opening in a weekend, we asked them to predict what was going to be the most popular when it opens, and they very quickly decided on Ant-Man, which turned out to be correct. And in fact, one of the things that we're finding is that groups, swarms, when they make predictions this way, are actually astonishingly accurate, and they're demonstrating intelligence that exceeds any individual member of the group, which is really part of our primary goal. Here's another example of how a swarm can make a decision. This is asking for an opinion, and again, we're asking what's a fair price for a movie ticket, an opinion, and here it's actually on a continuous scale. And what we see is the group comes up with $6.50. And what's astonishing is we've asked this same question to probably 50 different swarms of people, and every time it comes up almost exactly $6.50, which is this collective sentiment that maximizes the satisfaction of a group. Wow. And so let me see if I can I'll turn off the swarm, because we've seen that. But we did a really interesting study that we published a few months ago to try to quantify is a collective intelligence, when it's working together as a system in a swarm, smarter than the individuals who make it up. And so we asked a group to make a prediction. And the reason we use predictions is at least we can assess if they were right or wrong. And in this case, we asked them to predict the winners of the 2015 Oscars. And so we asked them to predict the top 15 awards, which is really hard to do. And so we did it two ways. Once we asked the group to first give us their individual opinions in a poll, which is basically going for the crowd approach. We asked them to give us their individual opinions in a poll, and then we took the most popular prediction as the answer of the crowd, and the crowd was out of 15 awards in the Academy Awards, got 7 correct. So 7 correct out of 15, which was actually slightly better than the individuals did on average by themselves. So by themselves, if you weren't pooling the knowledge, individuals got 6 correct. But when you took the most popular, they got 7 correct. So we did see that the crowd was smarter than a swarm, or smarter than an individual. But then we had that same group answer the same question together in real time as a swarm, and they got 11 correct. So they went from 7 correct as a crowd to 11 correct as a swarm. And to give you a point of reference, the New York Times blog made a similar predictions and got 9 correct. Mm-hmm. And so what we saw was a swarm of individuals who were not experts were actually able to match or even exceed the predictions of experts when they worked together as a system. And what's fascinating is that the swarm got 11 correct. And I think there were 70 individuals that we polled. Not a single one of those 70 individuals did better than the swarm. And so the swarm showed an intelligence that was better than all of the individuals. And you can ask, well, how does it work? Well, what you're having is the knowledge and the intuition of these 70 people being combined in real time. And what's fascinating is that when we asked the participants if they had seen all the movies in the that were up for the Oscars, nobody had seen all the movies. It's pretty rare to actually watch all the movies. In fact, some people had only seen a few of the movies. But when they're working together as a swarm, they're filling in the gaps in each other's knowledge. They're filling in the different, they're compensating for the different biases that they might have. Some people might have heard, seen a review of a movie here, or seen a prediction on a radio show. And so they're combining all the things that they've heard, all the things that they know, which movies they've seen, which movies they've not seen. They're just gut intuition. And when we pull it all together, they were able to make, again, 11 correct predictions out of 15, which gives them expert level intelligence from a group of novices who are not in any way movie experts. And we see this again and again when we field swarms and we ask questions and we tap into this combined knowledge and intuition of a large group.
That's absolutely fascinating. But let me ask you this: it's a detail that you've made kind of an explicit choice on, because you published a fantastic guest blog article on Singularity Weblog, which had probably like over 1,200 social media shares. And you talked about, a variety of swarms, such as a flock of birds or a school of fish. And yet your platform, UNU, is for some reason modeled after honeybee swarms.
Right.
So why did you make that specific choice? I mean, aren't we closer on the evolutionary tree to birds and to fish rather than honeybees?
Right. No, it's a great question. And we can even just take one step back a little bit and say, when you go all the way back on artificial intelligence research, which starts maybe back in the 1950s, the first place everybody looks for when doing artificial intelligence is nature. And so we look to nature because you're trying to create an artificial intelligence, and the real ones exist in nature. And starting back in the 1950s, the first path was to develop the development of the perceptron, which turned into artificial neurons, which turned into neural networks. And so neural networks are the primary way that most artificial intelligence research is being pursued right now. And it's a biological model. And what's worth mentioning is that nature is not a one-trick pony. Nature actually has 2 ways that it creates intelligence, at least 2. Maybe there's others that we don't know of, but it has neural-based intelligences, like our own brains, and it has swarms that biologists call swarm intelligence. And so swarm intelligence is where you have groups that are going to be smarter as a collective than they are apart. And that is why fish school, and that is why birds flock, and that is why bees swarm. Now, if you look at schooling and flocking, the primary benefits that we've at least identified thus far in flocks and schools is the ability of a group of a large group to move together as one. It's really I mean it's amazing what schools and flocks can do, and they allow groups to move as one, to evade predators, to navigate long distances, whether it's in the air or underwater. And so schools and flocks are amazing. And artificial intelligence researchers have looked at that for example, controlling drones, where there's a lot of work about using schooling and flocking to control a group of drones, getting the same benefits. Now, when we look at intelligence and we look at, well, where do we see real evidence of amplified intelligence? The most fascinating place is honeybee swarms, because honeybee swarms aren't using swarming to move as a group. And I say that because honeybee swarms will fly basically as a flock, and that's a flocking behavior. But when we talk about swarming for honeybees, it's a decision-making process. Honeybees use swarming to make decisions, and they actually demonstrate creation of a higher level of intelligence. And so let me give you an example of what honeybees do, because most people don't realize how amazing honeybees are. And so every year a honeybee swarm will spawn a new swarm, and that new swarm has to go that new colony. It has a new colony that will have to go out and find a new home. And so you'll have like 10,000 bees that will now need to go and leave a hive and find a new home. And that's a very dangerous and important process. And they need to pick a home site. And so what they do is they send out 200 to 500 scout bees that will actually search a 30 square mile area looking for home sites. And they'll bring back to the swarm dozens of potential sites that they found. And they can actually encode the position and the location of these sites in body vibrations. So they actually do something called a waggle dance, which encodes the exact location of these sites that they found. And then the swarm will go through a collective process using these waggle dances to select among a few dozen potential sites, and each of those sites is being evaluated across a whole bunch of different competing criteria. So when they pick a site, they need to decide, does it have enough internal volume? Like a site might be like a hollow tree, right? So they'll say, does that hollow tree have enough internal volume to store all the honey that they need for winter? Does that internal site have enough ventilation so they can keep it cool in the summer? Is that site insulated enough to keep it warm in the winter? Is it high enough off the ground from predators? So a very complex decision. I mean, they're making this incredibly complex decision with lots of different factors. And they do this collectively, where about 200 to 500 bees are doing this, basically this waggle dance, where they're all pushing and pulling on the decision, very much modeled. I mean, that's what we modeled our swarm after, how these bees push and pull on the decision. And one of the things that's inspired me is that some really amazing work has been done to study bees. There's a professor, Thomas Seeley, in Cornell, who did painstaking work to literally track bees. And what he found was that they will, even though it's this amazingly complex decision with picking sites across 30 square miles based on a dozen different competing criteria, they will pick the optimal site at least 80% of the time. So this is a group of 200 to 500 bees can solve this very complex problem, make this complex decision. Now, no single bee among them could make this decision. A single bee does not have the intellectual capacity to make a decision like that. But when they're working together as a swarm, they've amplified their intelligence, and they can make this decision that's beyond their own capabilities. And they make the best decision 80% of the time, which is an inspiration for us to say, well, can people see that same kind of benefit? If we can answer questions together, if we can form a swarm and make decisions, can we make decisions that exceed the ability of any one of our individuals? And nature shows us that that should be possible. And that's when we see these predictions, like predicting the Oscars, we're saying it looks like it's true. It looks like we can allow people to interact as a closed loop system and make decisions that are amplified, just like honeybees do when they make decisions that exceed their own individual abilities.
That's totally fascinating stuff. I was reading your paper here, which by the way I'm going to include a link to. It's called Human Swarming, a real-time method for parallel distributed intelligence, and it describes that in a few other fascinating cases that totally were revelation to me. I was never aware that bee behavior is so amazingly complex and intelligent at the collective level.
It is, and it's a great example of essentially an engineered intelligence. I mean, it was engineered over millions and millions of years of evolution, but it shows that nature has found more than just the neural method of building an intelligence. You can build an intelligence collectively, and what's also interesting is that when bees achieve this level of intelligence, they're doing it with just 500 bees working as a collective. They're not doing it with 100 billion neurons, which is,
Right.
When we talk about artificial intelligence research, we aspire to matching human intelligence, and people often forget that inside of our brain are 100 billion neurons, and that challenge of building an intelligence from the neural level might actually be harder even than we currently think. I mean, right now people are very optimistic about neural networks. It kind of goes in waves. 10 years ago, people were very pessimistic, and then 10 years before that, people were very optimistic. My personal view is that swarm intelligence has been neglected for the last 50 years, and it's just as amazing. And I think the reason it's neglected is that we naturally look to our own brain and we say, let's make an intelligence. We know our own brains, and bees, like you said, are very foreign to us. We only recently do we even appreciate the amazing decisions that they can make and the amazing things that they can do. But the evidence is there in nature that you can amplify intelligence substantially if you build systems that can work together in a closed loop manner, where it's biologists call it a superorganism, where they're basically thinking as one, but leveraging all the unique insights that come from all the different elements that bring information in.
You've already kind of responded to this question, but I still want to ask it so that we have a more explicit answer, because it's an audience question. And it goes like this. If collective intelligence is so great, then why stock markets are not that efficient? Why crowd does not get it right most of the time? Are humans really designed to swarm at the core because they get infected by each other's emotions and then act like lemmings? Islamic Jihad is a good example of the fact that humans can swarm, but that may not result in more intelligent actions.
Right. No, it's a great question. And I mean, a lot of parts of the question. So you talk about stock markets and crowds, and the fact that, you very often have basically a few leaders and a whole bunch of followers, lemmings. For me, I like to make another distinction between a herd and a swarm, because there's a lot of behaviors out there that are more like herds, and there's this old kind of old saying that a herd of sheep will jump off a cliff. If one sheep jumps off a cliff, the whole herd will jump off, and it's actually based on truth. It really is true that a single member of a herd can get startled, and then the whole rest of the herd will follow. And a herding behavior, in a lot of ways, amplifies noise, because that first sheep or elk that gets startled might just run in a random direction, and all the others follow based on this herding behavior. And it's adaptive for prey animals just to move based on one creature sees a danger and then they all move, but it doesn't necessarily breed intelligence. Mm-hmm. And so a lot of things that we look at out there and we say, well, why isn't it a collective intelligence? It's very often because it's got elements of herding built into it. and a swarming is different. And so the thing about a herd is that the decision is made sequentially. Somebody makes a decision, and then it happens first. Others see that decision, and they
Jump on the bandwagon.
right. They jump on the bandwagon, and they jump on the bandwagon. There's a scientific name for it called social influence bias. And social influence bias is this fact that uh, if you know what other people think, it has a great influence on what you think. And so we have all these tools out there right now that are amplifying social influence bias and are turning what could be a collective intelligence among us into basically a herd. And uh, I refer to the methods we have right now for online polling. So online polling, by and large, somebody puts an input in, and then everyone else can see it. And so if you go onto Amazon, for example, you can rate something 5 stars, and everyone else who shows up later will see, oh, well, somebody rated it 5 stars. That's going to influence your decision when you come next. If you go onto Netflix, and if you go onto to Facebook, and you're doing things with upvotes. So upvotes and giving things 5 stars and giving things thumbs up are all deeply influenced by social influence bias. And there was a study out of MIT and University of Jerusalem just a year or two ago, which went to quantify the effect of social influence bias. And they used a model that was similar to Reddit, where people can upvote. Somebody can make a decision and people can upvote. And what they found was that the very first upvote that comes in has an over 30% influence on what the next person is going to vote. And by the end of the process, it influences the final decision by 25%. So there could be thousands. So the first person can give an upvote randomly. 1,000 votes can come in, and that final decision is influenced 25% by that first input. And that's why we have these decisions that are being amplified online that can be based on just random noise. You can have a noise amplification where somebody gives something a 5 star, and then it influences everybody else. And the type of system that does that, where one vote can influence the next vote, is called an asynchronous system, where and an asynchronous polling system, which is basically prevalent all across social media, leads to herding. What's different about swarming, to answer your question, is that it's synchronous. Everybody answers together in real time. There are no leaders, there are no followers, there's no decision that anyone is following. It's all just emerging together. And so you greatly reduce the social influence bias, and you reach a decision that more truly reflects the signal as opposed to amplifying the noise. And you end up with what's ideally a decision that truly taps into the collective intelligence of the group, as opposed to tapping into the intelligence of the first few people who put input into the voting system.
So making the distinction between herding and swarming is crucial. It's very important, and I appreciate that very much, because it kind of clarifies the vital differences between the two. But let me ask you this: in your opinion, have you experienced the situation so far in your testing where swarming has been wrong or didn't work in some way or another?
Absolutely. So the thing about when you create an artificial swarm of a group of people, and it could be 50 people, it could be 100 people, it could be 200 people, you can't, you're still leveraging the knowledge and intuition and biases and experience of that group. And so you could end up with a swarm that takes on the personality of the participants. And so it could be, if I have a swarm made up of 100 college students, that's basically an artificial intelligence that reflects the personality that's different than if I have a swarm that has 100 senior citizens. They're both, they both have their own. I mean, that's the thing about a swarm, is that it can express opinions. It can have it can have intuition. It has human feelings built into it, and so they're not all identical. They're all different, and so you can have. We've seen a swarm that can be great at predicting football, and we've seen those swarms emerge. There might be other swarms that aren't great at predicting football, and so just like different people have different strengths and different weaknesses, we envision a world where different swarms have different strengths or different weaknesses. There might be a swarm that's really funny, and it comes out with all some people are using swarms to do like caption contests where they put a picture up and then they collectively come up with a caption. And there are some swarms that they're really, really funny, and other swarms that are really good at predicting football, and other swarms that have really interesting political insights. And what we do inside the UNU platform is we allow a swarm, when it reaches a decision, to tweet that decision or to post that decision on Facebook or on Reddit. And our hope is when this system goes live, that swarms will get a following the same way a Twitter, somebody who tweets gets a following. And a swarm will emerge that if a swarm that's really good at predicting college basketball will emerge with a following because it's proven itself as that its unique mix of input makes really good predictions. And the swarms that don't prove themselves won't generate a following. And so in a lot of ways, we're really modeling intelligence, because that's how intelligent creatures are. They're not all the same. Some intelligent creatures have strengths, some have weaknesses. It's based on how they're put together. And we hope to see hundreds or thousands of different swarms of all different sizes with all different mixes of people demonstrating different strengths and weaknesses. And then, the accuracy and the usefulness of what they come up with will be judged the same way the accuracy and usefulness of a person is judged. But the short answer to your question is, swarms, they're smart, but they're not clairvoyant. But what we do, but with all that said, the one thing that we do always see, regardless of how good or bad a swarm's answer is, it's almost always better than the individual predictions of those who make it up. And so even if I have a swarm of people who aren't really good at predicting football, the swarm is still better than those individuals. It's just that those individuals happen to be terrible. Right? Whereas if I take a group of people who are good at predicting football, the swarm will be even better than that. And so you can imagine this idea of, well, what if you create a swarm of experts? A swarm of experts can create a super expert. And those are the types of things that we're really interested in exploring. That's actually one of the things that's on our horizon, is looking at, can we field swarms of experts and see if we can achieve a super expert.
Yeah, this is totally fascinating work, and which is, of course, why I wanted to have you on my show. But let me ask you this: what's the most surprising thing that you have learned about swarming?
That's a great question. I think, and this might not sound that exciting, but to me, the most surprising thing is how much people like to do it. And maybe it shouldn't be surprising, but one of the big questions for me when we first started working on it, because this started out as a research technology, and then we said, well, let's make this available to just average people. And the big question was, well, average people want to swarm at all? If they don't want to swarm, then they won't do it. And what's fascinating is that people love to do it. They think it's fun. They think it's fascinating. They actually feel more connected to all the other people who are doing it. They actually feel a sense of unity with this group. And so it creates community in a new way. And so it was very surprising to me. And yet, if you look back at the social science research, you really shouldn't be surprised, because people are tribal creatures, and we're hardwired to want to be connected in that way. And it's a very similar reason why people like to play team sports, because they're connected intimately with other people. People like to play in a symphony because they're playing music with a whole bunch of other people in a synchronized, deeply connected way. Things from in fact, it actually goes all the way back to military research, and militaries have known this for a long time, that they have people march in step, not because armies have any value of marching. And maybe a few hundred years ago, but marching just creates a feeling of unity among among people. People like to feel like they're part of a group. They like to feel intimately connected with a group. And if what's fascinating is that in the current world of social media, which we call social, most of that is people passing notes to each other offline. Like I can post something on Facebook and somebody else will go up, give it a thumbs up, the next day, but we're not really synchronized. We're not really there at the same time. There's not really a sense of unity. But when we let people come into UNU and they're there together in real time and they're considering the same question and they're all deciding together, who's going to be the next president of the United States, whether or not the answer was their first choice or not, they feel connected to the other people. And they actually also feel like they have more buy-in to the decision because they were part of it in real time. And so I think, so the short answer to your question is the thing that surprises me most is really, in theory, yes, this should be connect with the basic way humans are built. But in reality, it's really true. People really do feel this sense of unity when they're interacting with people together in real time.
And you said that others can test your platform. Tell us how is that going to work if for example, other researchers want to give it a try?
Right. So any researcher who wants to create their own account on the system can do that now. It's just unu.ai is the site, and researchers can use it to to field their own swarms and test swarm intelligence themselves. And there's a number of researchers out there who are currently looking at that. And we're excited to have as many people out there as possible, really testing the limits of what swarms can do. How smart are swarms? How well is a swarm able to create an optimized decision among people? And so it's definitely available out there for researchers. It's also available out there for average people who want to come in and just use it. We have people who are interested in fantasy football, for example. And fantasy football people have a lot of decisions to make and they take it very seriously. And so they can come into UNU, they can create a swarm and they can ask a question and they can get really, really smart answers. And the predictions keep turning out to be, again, very accurate and more accurate than the individuals would make. In fact, we had a group that formed a swarm before the Super Bowl, and they wanted to test the intelligence of that swarm. And so they figured they picked 20 prop bets that had Vegas odds. And the thing about prop bets is that the Vegas odds make them work out to 50-50. So you should have, and they said, well, can they beat the Vegas odds? And so they placed 20 prop bets as a swarm, and they came out 25% ahead on their returns because they really were smarter together than individuals. And the thing that's crazy about prop bets is some of those bets are really silly. Like one of the bets was, what color Gatorade will get poured on the coach at the end? Well, can you really be intelligent and come up with that answer? Well, maybe if you have 50 people who all have some sense of intuition of what they've seen on previous games and what maybe they can beat the odds by combining their knowledge and intuition. So, but for most people, it's just fun. It's fun to be able to see, can a swarm come up with a good prediction or a good decision, or we've had groups use it to make really kind of mundane decisions, like where should we go for dinner? And so that's actually that's a problem that everyone faces. Where should we go for dinner? And if you have 6 people trying to decide where you're going to go for dinner, that's tough. And so one example that was fascinating was we had a group say, where should we go for dinner? And they each suggested a different alternative. And so they had Chinese food, Mexican food, Indian food, and then the swarm starts to answer. And what was interesting is if you just took a vote, in this particular case, if you just took a vote and say, where should we go for dinner? You take a vote. In this case, 2 of the people voted for Indian food and the other people were all split among the other options. And so if you took a vote and you took the most popular answer, they would have gone to Indian food. What that didn't account for was the fact that some of those other people just hated Indian food. And so it would have created a situation where there were a number of unhappy people if that was the answer. When they did it as a swarm, what happened was two of the people were pulling to Indian food, the others were split, so the puck started moving towards Indian food. But when the swarm saw the puck moving towards Indian food, those people who were pulling towards other options, somebody who was pulling towards Chinese food said, yeah, I wanted Chinese food, but I cannot live with Indian food. So they changed their strategy from pulling for Chinese food to defending against Indian food. And then somebody else did this. Somebody who was pulling for Italian food might have done the same thing, also changed their strategy. And so everybody's changing and moving in real time. And so that most popular answer, which maybe would have gone to Indian food, actually suddenly stops and suddenly starts moving in another direction. And all these types of negotiations are happening in real time. And it then went to Italian food. And then if you poll the group after and you say, are you satisfied with that answer of Italian food? Yes, the group was more satisfied with the answer of Italian food because it meshed with the desires of the whole group better than a simple vote that is a popularity contest. And so swarming is really interesting for making simple decisions like where should we go for dinner to complex predictions of who's going to win the Super Bowl. And again, and shouldn't be a surprise because creatures as simple as bees can make a far more complicated decision than where should we go for dinner. They could decide where their home should be, and in fact, it's a life or death decision for bees. If they pick the wrong site, they could all die. And yet, nature has found that swarming is the way for them to make that decision and find the optimal answer and not reach a stalemate, because a stalemate is also death for a group of bees, right? So the thing about swarming is they all get buy-in during the process. And so then at the end of a swarming process for bees, they'll all go fly off to the same site. They won't just all fly off in different directions. It would be as if a group of people said, well, you guys can go to Indian food. We're going to Italian food. See ya. And what swarming does is it actually gives everyone buy-in so they don't feel like, they feel like, yeah, they were all heard. And we found the decision that really we can all agree on.
That's totally amazing. The repercussions of that kind of a decision-making process are profound, I think. But one thing that's very important, clearly, is the interface.
Yes.
And so I think that's where your kind of greatest innovation lies in kind of translating what you've observed in, let's say, the swaggle dance in the bee swarm into a kind of a platform that mimics or allows for that behavior and outcome to happen in a dynamic sort of non-biasing kind of a manner. But let me ask you this. So you're currently doing that through a kind of a computer mouse interface and so on, which is the classic interface. But are you familiar with the brain-to-brain computers that, for example, Professor Miguel Nicolillis is working on?
Right. So absolutely. So we currently, as you saw in the demo that we showed, people can use a mouse to control that little magnet. You can also use a touch screen, which for some people they like better. They can put their finger on a touch screen. But we've looked at a whole bunch of different types of interfaces, and basically a neural interface is something that we've also looked at and pondered, and we think that that's also viable and interesting. Our focus right now is to get lots of people to form swarms, and so we're trying to make it as use the most commonly available interfaces possible. But it's definitely fascinating to think about using all kinds of interfaces, whether it's we've looked at eye tracking, we've looked at EKG type of things, and all of those are possible and interesting and potentially long term could be the way people want to do it. Right now, just with the mouse or a touch screen, it works really well. And in the video that I showed, you saw the little magnets that people can pull on the puck. And what's important about it, and what's interesting, is it models the thing about swarms. Actually, both swarms and brains. Because swarms and brains are actually very similar. They're both a collection of individual units that that produce an activation signal. In the case of a bee swarm, the activation signal is a waggle dance, and it has different levels of intensity. And a more intense waggle dance is a higher level of activation. In a brain, it's, a neuron will have an activation signal, and what you have in both of those is basically all of these signals working in parallel, and a decision emerging. But what happens is that those signals have to be maintained over time. They're not just a single signal, but they have to be maintained over time, which is why we used the magnet metaphor and the fact that people have to pull on the magnet. And what happens is if the puck starts moving away from the magnet, your magnet's getting further, and so your signal is getting less. And so you have to actually keep the magnet, you have to actively be engaged the whole time to keep the magnet next to the puck for the signal to be maintained over time. And what we find is that some people, if they're really confident in their answer, will work really hard to keep the magnet next to the puck. If they're less confident, then the magnet might drift a little bit further away. And so what we're seeing is we're capturing different levels of conviction from all the different people. And it's these different levels of conviction combined with their different levels of knowledge and expertise that allows this unique mix that allows them to reach an optimal decision. And so so the interface, lots of interfaces are possible, but they have to have this subtlety of forcing people to maintain their focus across the decision for their activation signal to be counted fully.
And let me ask you this then: does that mean that arguably the logical and perhaps ultimate culmination of this kind of a process of evolution of the swarming and the interfaces and the brain-to-brain communication and so on will result probably in all of us kind of becoming the Borg?
So, the Borg is obviously the most negative connotation that you could imagine for collective intelligence, and
But they're the perfect swarm, aren't they?
Possibly. It's a little bit hard to know what the individuals contribute in a Borg because it's science fiction, but I would again look to nature as opposed to science fiction, in that if we look at like a bee swarm, the individual bees that are participating in the decision are actually the 200 to 500 most senior bees who have the most knowledge and most experience, and they're the bees who go out and actually search the environment. And so they're finding collective decisions, but they're not minimizing the participants. They're actually they want those participants to be intelligent explorers who go out and collect information, as opposed to being automatons. And I say that because people often refer to the Borg as a hive mind, and they use the word hive pejoratively, and it's often because people have a misconception of how a hive works. People often think, okay, there's 10,000 drone bees, and they all just follow the orders of a queen bee who has a directive, and then they all kind of work. And really, that's not how it works at all. So a queen bee has no input in the decisions of a hive. And in fact, it's the 10,000 drone bees aren't part of the decision either. It's 200 to 500 of the most senior scout bees who have the knowledge that make the decision. And so, at least in the case of nature, the optimal type of collective intelligence is one where you have a group of individuals who are skilled and who are diverse and who bring different opinions back, and they basically consider those opinions and negotiate in real time. And so, yes, they will come to a decision that they can all agree upon, but they're not all saying the same thing. They're not all thinking the same thing. It's not groupthink, which really would be a group just taking a poll and everyone following a few leaders. It's really a group thinking together and really negotiating thoughtfully and coming to a solution that is the best for the group, and takes advantage of all their different opinions, all their different knowledge. So I have a more optimistic view of what the future could be. But of course, the science, you have to be mindful of the kind of the dystopian science fiction visions, because those are the things that we need to work against. Those are the things that we need to push towards technologies that allow for a group to behave as an ethical collective intelligence, not a a, a drone based mob. And that so
Louis, unfortunately, time is advancing here, so I only have a couple of 2 or 3 more questions. So the first one is, what is the biggest misconception about your work that kind of perhaps is really bugging you and you want to clarify once and for all?
Right. Well, I don't know if it's a misconception, but we think about our work in the in this in the hierarchy of artificial intelligence, and sometimes people say, well, there's people involved, it's not artificial, right? And I understand that reaction. And the thing is, people can't swarm, right? So if people don't have the natural ability to swarm, and so what we do is we're using software and some artificial intelligence techniques to allow people to form these artificial swarms. And when we're creating an intelligence, and this intelligence is different than any individual among them, we're creating this new emergent intelligence. And so we definitely see it on this spectrum of artificial intelligence. The difference is really simply which type of natural intelligence are we modeling. Most artificial intelligence work is modeling neural based intelligences, and that's great. We're artificially modeling swarm-based intelligences, but the intelligence that emerges, in our view, is a purely artificial intelligence. It might have a personality that's unique and different than any individual who comprises it. It might have a level of intuition or ability to make predictions that exceeds any individual who comprises it. And so we do believe that it is a true artificial intelligence. But we're very proud of the fact that people are in the loop. We don't apologize for that fact. We, again, as we said, our hope is that that's the safer approach to building smarter systems, is to actually have those smarter systems have human emotions and human values and human sensibilities as an integral part of the system.
That's I'm sorry about this.
Bless you.
Thank you. That's absolutely amazing, and I cannot stop thinking about the potential for, let's say, the wider, let's say, political implications that any kind of decision making process of that kind would have over our democracy and our form of government and sort of everything along those lines. It's totally fascinating and profound. But let me ask you this. What's the best place for people to follow you and your work?
Right. So they can find out about our company and our work at Unanimous AI. Just unanimous.ai is our website, and we have a blog on Unanimous AI that talks about all the various studies that we do and new swarms that we do and the questions that we ask swarms. Also, if you go to unanimous.ai, if people want to sign up to be a beta user of the UNU platform, they can just send in their name, and we can give them a password, and they can go in and they can try swarming for themselves. The UNU platform is at unu.ai, and if you go to unu.ai, you can go there. You need a beta password, which we're happy to give people, and they can request it from that site as well. But for us, anyone who's certainly an enthusiast about future technologies are great users, because they think they have interesting feedback for us, and they're interesting contributors to these type of swarm decisions. We had a group last week that was making all kinds of interesting predictions about self-driving cars, because these were all futurology and people who were interested in futurology, and they wanted to ask the question, are people going to be comfortable getting in a car that doesn't have a steering wheel potentially and is driving at highway speeds? And we can all have our own prediction, but it's fascinating when you see 100 people thinking as one making that kind of prediction. And so it's great to get people who are interested in helping make those kinds of predictions, or maybe they're interested in fantasy football or politics. But but we're beta users are now we're now at the point where we're signing up beta users and people are having fun seeing what it's like to swarm. And if people are academic researchers, even better, we're happy to support them to do their own studies of swarms.
Fantastic. And the last question that I always ask of my guests on my show is, what's the final message? What's perhaps the one thing, the most important thing that you would like our viewers to take away from this conversation with you today?
Right. I think it's that that groups of people are smart. Groups are smart, and we have just scratched the surface in tapping into the value that groups of people have if we can use technology to combine their knowledge and intuition. And swarming is a way to do it. It's the way nature tells us that we could best leverage that. And so a great way for people to appreciate that is to try it for themselves. So again, we're happy to have beta users who want to see what it's like to be part of a swarm.
Dr. Louis Rosenberg, thank you very much for being with us today.
Yeah, thank you.
Singularity.